Hey everyone, pop quiz time. Thought it would be a good chance to check in with people and give you a little bit of an opportunity to practice some things that you should be knowing by now. So just be aware, question 2D requires some viewer participation. I'm expecting people to do something in the comments below. So that's a little bit of my way of checking to see if you know what you're doing. Also, just to see if you're following along with the videos. So let's just have a look here. This is a pop quiz, so the intention is that you do this yourself, and we'll go over the answers in just a sec. So I would pause the video, give it a try, and when you unpause, the answers will be coming at you. So pause it right now and do them. Okay, so the miracle of the video is that you can pause and you can take as long as you want, and I'm going to hope that you actually got them done here. So let's have a look here. Determine the exact value. No decimals. We need radicals. So just a little bit of a thing here. The exact value, that's usually telling you you better be using special triangles. And of course, that is something that I definitely want people to be doing. Yes, you should know how to use your calculator, but there's not so much a learning with that. The special triangles are what's going to be more effective later on. So let's have a look here. Is 60 degrees a special triangle? You bet. So the first thing I would do to solve this problem is I would just sketch 60 degrees. So that is about a 60-degree angle. Now you know that the 60-degree special triangle, so this one here is 60. This is root 3, this is 2, and this is 1. Now if you don't have this memorized, that's what you got to do. You got to get it memorized. So once you do have this memorized, now we can simply say that cos of 60 is equal to adjacent over hypotenuse. So the adjacent side for 60 degrees is 1 and the hypotenuse is 2. So the value of cosine 60, if you used a calculator, would be 1/2. Okay, for B, tan of 330, that's when you spin all the way around and you're just 30 degrees shy of 360. So that's what it would look like. Now what we have here is we've got a 30-degree reference angle. So the first thing you might do is you might write the reference angle as 30 degrees. Then you go to your special triangle, which we actually just drew above, but I'll redraw it below. Here's 30. Here's root 3. Here's 1, and here's 2. Adjacent tan is opposite over adjacent. So tan 30 equals opposite over adjacent, so 1 over root 3. And of course, that means that tan of 330 is equal to 1 over root 3 as well, because they share the same reference angle. The only difference is we're in quadrant 4. So in quadrant 4, tan of 330 is negative. So if you went to a calculator and you typed in tan of 330, you can get negative 1 over root 3. Okay, for C, negative 135. So this is a negative angle. It's going in that direction. We've got a 45-degree reference angle. So I do know, let's see, with our 45-degree triangle here. So cos of 45 would be equal to adjacent over hypotenuse, so 1 over root 2, which tells me cos of negative 135 is equal to the same thing, put the degree sign in the bracket. It's the same value, except now we just have to decide whether it's positive or negative. Since it's in quadrant 3, cosine is negative there. Ta-da. Sine of 180. Okay, this is the one where you could draw it like this, and then you could lay flat your terminal arm there. But I actually would find this more useful, and this was from the trigonometry assignment, to draw the sine wave looking like this, where here's 360 and here's 180 right here. So what I can do is I can tell that sine of 180 is actually just equal to 0. And I can do it right away without having to do any adjacent, hypotenuse, opposite kind of business. So that's the use of those graphs. They're not very handy for figuring out something like sine of 45, but they're great for 180, 360, 90s all the way up here, 270s all the way down there. Okay, and then this next one, tan of 780. Well, how many times do we spin around? So one spin is 360, another spin is 720, and we're going 60-degree reference angle beyond that. So tan of 60 degrees, I feel like we've almost done that, so I'm just going back looking at this guy here. You can see that tan of 60, here's your 60 in there, it'd be root 3 over 1, and therefore we can conclude that tan of 780, which is also in quadrant 1, it's the same quadrant, is also root 3 over 1, or just root 3. So all of these required 0 calculator. These are all exact values, no rounding, no 1.7 for root 3, that kind of business. Okie dokie. Solve. So these are the other style of questions that you'll have to do a fair bit of, and they're coming back in full force in Pre-Calc 12 for those of you moving on as well. So what we do here is, this part is just telling us the angles should be between 0 and 360. So the video on coterminal angles, you should know that there's an infinite number of ways we can rotate around, but we'll be restricting the domain, so we're not going to have an infinite number of answers. Okay, so what the thought process here is the first thing you got to do is you got to figure out what is the reference angle. So you draw your triangle. Now when you see a root 3 and a 2, that should be a big fat clue that we need to draw this guy here. And we're talking about sine, so we're talking about opposite, and then this is the hypotenuse. So the opposite and hypotenuse, that would mean our angle is right in here. So all you need to do is you just need to know what this angle is, and this is 60 degrees, and that's simply something that we've memorized. So the reference angle is 60. Okay, first step is always figure out the reference angle. Then you can say, okay, so it's a 60 degree reference angle, but what quadrants is it in? So because this is positive, this is quadrant 1 or quadrant 2, because sine is positive in quadrant 1 and quadrant 2. So what we're going to do is we're going to go over here, we're going to draw in quadrant 1 your 60 degree angle. In quadrant 2, this is also 60, but that means that one of our answers is, let me just grab my other color, one of our answers is 60 degrees, and the other answer is when you spin around and you get to 120 degrees. So there's two answers for theta. Theta equals 60 degrees, and it equals 120. Okay, with tan, now when you see -1, that's not a fraction, so you might not be thinking like opposite over adjacent, but keep in mind this is the same thing as -1 over 1. So what kind of special triangle do we have here? It's this guy. And that should tell us the reference angle is 45. So theta reference equals 45. So you go over here and you go, okay, well, what quadrants is this in? So because it's negative, tan is negative in quadrants 2 and quadrants 4. Remember, if you're rusty here, I'm always referring to this. All students take calculus. So tan is positive in quadrants 1 and 3, so it's negative in quadrants 2 and 4. So what we do is we draw a 45 degree reference angle in quadrant 2. There we go. And in quadrant 4, same thing. Okay, so the two actual angles we have, one of them goes around like this, and that is 135 degrees, and the other one spins around like this, and that is 315 degrees. If you're not totally sure where I got those numbers from, remember, you can always calculate the quadrant 2 angle is always 180 minus the reference. And in quadrant 4, it's always 360 minus the reference. Okay, the third one here, C. 2 cosine equals -1. Okay, so this is just a small little trick here. We got to get rid of the 2, so we're actually going to move to the other side. So we wind up getting cos theta equals -1 over 2. Okay, so again, which special triangle is the one we're going to use here? 1 over 2 reminds me of this guy. There's a right angle, and we're talking about cosine, so the adjacent is 1, the hypotenuse is 2. So I know this is, this is the 60 degree angle. If you're like me, you often get it confused, 30 and 60. The 60 is across from the root 3. Just remember, your two angles are 30 and 60, while 30 is across from 1, which is the small side, 60, which is a larger angle, opens up to root 3, which is a larger side. So this tells me that the reference angle is equal to 60 degrees. Now, this is cosine equals negative 1 over 2. So this tells me that in quadrants 2 and 3, this is quadrants 2 and 3. So what we do is we go over here and we draw a 60-degree reference angle in quadrant 2, 60, and then in quadrant 3, there's 60. Okay, so my actual angles now. This is where I gotta be careful. I threw in a little bit of a curveball here. One of your angles is gonna go all the way around like this, so that's 120. Now, normally we'd be looking to get here by spinning around even further than 180, but our restriction is that we cannot go larger than 180, so that is out. What we can do is we can go into the negatives here. So we're going to go negative, and we're going to spin this direction here. That's negative 120. So, there we go. There's our answers, 120 and negative 120 in that specific domain. Cool. Okay. If you got all that right, that's fantastic. Now, for D, I'm not going to go over any answers because you are the one who's making the question. It says create your own equation where you solve for theta. So something like 2a, 2b, and 2c, and you've got to write the solutions in the comments below. You don't have to show all the work, but I want to see the equation, and then I want to see just the answers. And of course, I'm only interested in things like special triangles. So if you did something like tan theta equals 0.4, not interested because that's not a special angle. But if you did something like tan theta equals root 3 over 2, that sounds good. You can also make your domain whatever you want it to be. So you could write your domain like between negative 180 and 180 if you like. Okay. Anyway, that's just a little check to see if you're following along. So do that, and I'll be looking for your answer in the comments below. All right. See you later.